Hey guys, how are you doing? I hope you all are doing well. It's very warm welcome to you all on our channel Euclid Mathematics. Today I am here with one of the magnificent topic from complex analysis, which is a Mobius transformation, which has lot more weightage on CSIR-NET, SET and GATE exam and multiple other competitive exam too. So in my today's video, I will explain topic which is a Mobius transformation, or we generally call it as the linear transformation. Mobius transformation, linear transformation or fractional transformation. That is bilinear transformation. Okay, so in competitive exam, this type of the question we generally ask, like SET exam, NET exam and GATE exam too, and other MPSC type of exams also. So in my today's video, I will explain Mobius transformation with one of the example from CSIR-NET exam. So Mobius transformation we generally call as a bilinear transformation or linear fractional transformation. So these three words are similar meaning. Okay, three words are having similar meaning. So don't get confused if they ask for the bilinear transformation, or if they ask for the linear fractional transformation, or for the Mobius transformation. So three of these terms mean same. Okay. So let's get started. Here first question from the Mobius transformation. Okay, so here we have given question. Let's read the question. Define H plus. Okay, so H plus is given Z belongs to complex and all Y strictly greater 0. Okay, so you can see it here. H plus means a positive upper half plane. Okay, so don't get confused that H plus means just as a notation. It is not a notation. That you can see it here. H plus means all Z which we have to take it from the complex, and there exist all number y which bigger than 0. Okay, that means all number from positive y axis. Okay, so here H plus means upper half plane. Okay, y bigger than 0 means upper half plane. Okay, so H minus it is given lower half plane, that means y smaller than 0. Y we have to check it for the y axis. Okay, y smaller than 0, that means lower half plane. L plus, okay, that means left half plane where x real axis is a positive. Okay, x bigger than 0. Okay, now L minus means Z belongs to complex, but x smaller than 0, that means it is a negative on x-axis. Okay, x negative on x-axis. Okay, so it is a real half plane which is a negative. So then we have to find out whether function f of z, which given z by 3z plus 1, okay, which maps positive half plane onto positive half plane and negative half plane onto negative half plane. Option B says that positive half plane onto negative half plane and negative half plane onto positive half plane. Okay, so we need to understand H plus H minus by using our given question. Okay, it is given here. They are just a notation, but they represent positive and negative half planes. Okay, so similarly for the third option, positive half plane to left positive half plane. Okay, that means it is for the imaginary axis and it is for the real axis. Okay, similarly H minus to L plus. Okay, positive half plane to negative x axis and positive half plane. Okay, negative half plane means negative y axis to positive x-axis. Okay, so we have to check under this function which half plane map to which half plane. Okay, that means positive maps to negative or negative maps to positive. Okay, so let's get started our solution here. A question, it is quite easy. Okay, so for finding the solution we admit two methods here. Okay, so we can solve this question by two ways. Okay, just one is a trick. Okay, that trick gives us answer in a quite second only. Okay, because of that these tricks are more important in competitive exam. That's why these tricks are we have to apply and we need to remember it. Okay, and other trick, other way we can solve this one as the regular solution method. Okay, so let's get started our solution. Okay, so in our options which given this positive and negative half plane. Okay, let's draw the H plus. Okay, H plus means we have given H plus as all y such that y strictly bigger 0. Okay, that means strictly greater 0 y it is given here. Okay, now represent y strictly greater 0 in our xy plane. Okay, then we can see it here. Okay, y strictly bigger than 0, that means we want the value where y only positive. Okay, so we have to take the value from there. Okay, so you can understand that one, just an observation only, because y bigger than 0, that means we have to take upper axis only y where y positive. Okay, here y bigger than 0, y smaller than 0, that means lower axis. Okay, lower y axis. X positive, that means this side of the x is bigger than 0 and this side of x is smaller than 0. Okay, these are the H plus, H minus, L plus and L minus represent here. Okay, now our first option say that H plus maps onto H plus and H minus maps onto H minus. Okay, now consider any point, okay, which belongs to H plus, that means the point which belongs here where y is positive. Okay, so we know that y is the imaginary axis, so we get the all values for y I, 2i, 3i in this form. Okay, all this value for I, y is in the form of I. Okay, because it is imaginary axis and this one is a real axis, so we get the value for x, it is here. Now take any element from the y-axis. So I let's consider positive y-axis, I is there. Okay, so I belongs to positive h plus. Okay, so you can see here I consider I from the positive axis of y. Okay, so when h plus is there, then I belongs to h plus. Okay, then we have f of z, which is given z upon 3z plus 1, which is the example given in our example. Okay, value for f of z, z upon 3z plus 1. Now substitute that I as a z. Okay, so I consider z as I, so f of z, which is equal to z upon 3 into z plus 1. Okay, z substituted here I. Okay, now let's find out what the value for f of I gives. Okay, so in this case try to rationalize, okay, the denominator. So multiply opposite term of this 3i plus 1 here and divide it is here. Okay, so 3i minus 1 upon 3i minus 1. So I multiplied 3i plus 1 as a 3i minus 1 and I divide 3i plus 1 as a 3i minus 1. Okay, this term remains same. So go for the multiplication of numerator here and denominator here. So you can see it here, I into 3i. It is a 3 into I square. Okay, and I square, it is having value minus 1. So it is a minus 3 and I multiplied by minus 1. It is a minus I. Okay, so this is the multiplication for numerator here. Now let's go for the denominator. So 3i plus 1 multiplied by 3i minus 1. So easily we can see that this is the form of a plus b multiplied by a minus b, which is a square minus b square. That means 3i square means minus 9. 3i square means 3 square is a 9 and I square is a minus 1. So minus 9 here plus b square minus b square. So 1 square is a remain 1. Okay, so go for the further calculation. Minus 3 minus I. Okay, take negative common from here and minus 9 minus 1 minus 10. Okay, so negative cancel, 3 upon 10 plus I by 10. Okay, now you can observe that f of I, what it comes, 3 by 10 plus I by 10. That means a plus bi. That means x plus iy. The value for x is a positive, y is a positive. If value for x positive, y positive, then we can easily say that positive come into the first quadrant. Okay, first quadrant contain all the value for x and y are positive. So if both are positive, then we can see that first quadrant come into the first half plane. Okay, it comes to the h plus. So this is the upper half plane. Okay, that means our first option, it says that h plus maps onto h plus. Okay, that means I took it here, value for I, z is I, and it gives the value for f of z, which is 3 by 10 plus I by 10. That means it is also positive value. Okay, that gives upper half plane onto upper half plane. Okay, this is a mapping from upper half plane onto upper half plane. Now let's do it for the lower half plane onto lower half plane. Okay, now consider any point from the lower. I consider the lower half plane as z is equal to minus 1 minus I. Okay, you can see that x is a minus 1, y is a minus 1. So which belongs to here lower half plane. That means third quadrant here. Sorry, third quadrant here. Okay, x minus 1, y minus 1. Minus 1. Okay, so we can see that z is from the real imaginary axis. Okay, which is a negative x, y negative, it is here in third quadrant. So now let's verify whether that points z maps to upper half plane or lower half plane or left or right. Okay, now let's check if I put z is equal to minus 1 minus I. Okay, so z which is equal to z 5 minus I. Okay, and 3z plus 1. So 3z, 3 into minus 3 minus 3i plus 1. Okay, so after calculation you get the 13 here. Okay, this is just an easy calculation, so I ignored this one here, but you can find that one by your own. Okay, okay, this is not the difficult calculation, you easily can get that one. So you can see that x I got it here 5 by 13 and y is minus 1 by 13. Okay, that means x positive, y negative. Okay, on which quadrant it comes here? 5 minus I by 13. Okay, 5 by 13 minus I by 13, 1 by 13. Okay, so that negative axis, x is positive here and y is negative here. Okay, so you can see that here that I consider the point from L minus, that means x smaller than 0. Okay, x smaller than 0 I consider here from the L minus, and I got the point x positive, y negative. That means x positive, y negative, it is in fourth quadrant. Okay, if I consider point from third quadrant, I got the image in a fourth quadrant. Okay, so then it maps lower half plane. That means x negative to x positive. Okay, so L minus maps to L plus. Okay, so L minus maps to L plus. Now let's check out here our options. So in our first option, it gives h plus maps to h plus, h minus maps to h minus. That one is correct. Second option, it says that h plus maps to h minus, but it is not possible because I got the upper half plane map to upper half plane. Okay, and lower map to lower. So the option B wrong. Option C, it says that h plus to L plus, never possible. It is also not true. We found it in our answer. This is also wrong. Okay, and fourth it h plus goes to l minus and h minus goes to l plus, never possible. Okay, so for finding these values you have to consider the value from their quadrant. Okay, upper half plane means you have to consider the value from upper side of the half plane. H plus minus means you have to consider the value from lower half plane. Put it into the f of z and just figure it out where that point goes. Okay, where the image of that point goes. Okay, l minus to l plus, you can see that here negative half plane goes to positive, negative x-axis goes to positive x-axis. Okay, so I hope so you all have understood this way of finding the images of functions. Okay, f of z. So that method, it is quite easy to find out the solution. But I'm also having one more method. Okay, that if we apply that method we can get the easily answer. Okay, now let's get started to the second method of finding whether the images are going. Okay, let's go for this. So we can see it here, the alternative method for above example. Okay, so this is the actual definitions from bilinear transformation. Okay, Mobius transformation. So we convert our f of z in the form of az plus b upon cz plus d. Okay, and abcd all are from the real number. If that ad minus bc, that means a multiplied by d minus b multiplied by c, if the value for that ad minus bc is bigger than 0. Okay, remember here the value for ad minus bc bigger than 0, then positive half plane maps to positive half plane. Okay, upper half plane to upper half plane and lower half plane to lower half plane. And one more condition here, if ad minus bc is smaller than 0, then we say upper half plane map to the lower half plane. That means h plus goes to h minus and h minus goes to h plus. Okay, this is the second condition. Now let's verify our example with this property. So our property, it says that az plus b upon cz plus d. Consider our example in this form. Az, that means 1, we have given example z upon 3z plus 1. Okay, now convert that one in this form. So a into z, that means 1 into z plus b, it is not present, so mention it is 0 here. That means 1 into z plus 0 means itself a z only. Okay, we have to understand one thing here, that numerator and denominator part has to be remain same, because we cannot change in our given f of z. We have to convert f of z in this form. Okay, upon cz plus d, that means 3z plus 1 means c is a 3, z remains and d is 1. Okay, now after observation I got the value for a is 1, b is a 0, c is a 3 and d which is the 1. Okay, all are the value from this result. Okay, so let's verify ad minus bc. So ad minus bc, a multiplied by d which is 1 minus b multiplied by c, so 0 multiplied by 3, it remains 0, so 1 minus 0, it is 1. Okay, and which is a strictly bigger 0. Condition hold for this first condition. Okay, so we can see that f of z maps h plus to h plus and h minus to h minus. So this is the value which gives upper half plane to upper half plane and lower half plane to lower half plane. So I hope so you all have understood the second way, alternative method for first example. Okay, both of the methods are quite easy to find out the images of our given function. Okay, so I hope so you all have understood my today's lecture. So if you have any doubt, comment me in the comment section. I will help you with your doubts. Okay, and if you wanted to see more videos like this, okay, you can go through my playlist. I uploaded more videos on complex analysis also, linear algebra also, real analysis also, again calculus of variation, integral equation, all subject from higher mathematics. I uploaded video on my channel. So if you wanted to see, you can go through my videos. Okay, so thank you everyone. Thank you for my today's lecture.